Alrighty, let's take a look at this question. So we're asked to find the slope of the tangent line to this curve at the point 2, 2. And of course, in calculus, if you hear slope of the tangent line, you should know that's the same as the derivative. All right, so we need to take the derivative of this. We don't like square root symbols, so we're going to change that immediately to powers. So x plus y now to the 1/2 plus, and I think I might write that as x to the 1/2, y to the 1/2 might be easier, rather than brackets around it to the 1/2. So x to the 1/2, y to the 1/2. For that second one, you can't do it with the first one because it's adding. Okay, equals 4. Okay, we're now ready to take the derivative. So I'm going to start over here on the left. So x plus y to the 1/2, that's going to involve chain rule. So you bring the exponent down front, you reduce your exponent. I always do this. I write the brackets first, and then I go back in and fill the inside in. Because the inside stays the same, and we're going to use chain rule now on the inside, which means multiplied by the derivative of the inside. So 1/2 x plus y to the negative 1/2. Now the derivative of x would be 1, and the derivative of y would be, well, it has to be with respect to x, so we write dy over dx. You can also put y prime. I'm just used to dy over dx. Give a tribute out to Leibniz. Okay, that one is now done. Plus, now we're going to look at the next one. Oh, look at what we got going on here. We have an x times a y. They're both variables, so that means we have product rule. So we would have first x to the 1/2 times this derivative of the second, so 1/2 y to the negative 1/2, plus the second y to the 1/2 times the derivative of the first, 1/2 x to the negative 1/2. Oh, I missed something there, didn't I? Okay, let me go back to when I did the derivative of y, I should have wrote dy dx. So I'm just going to do that in red, the shameful color of mistakes. Okay, so we should have a dy dx there. All right, and then we keep going, equals the derivative of 4. Don't write 4 because the derivative constant is 0. Okay, now let's see. We could go about isolating dy dx, but since they said just find the slope at the point 2, 2, I think it might be easier if we just sub in 2 now. So 2 for x, 2 for y. I suppose we could clean this up a little bit. I'll do that on the next step. So 2 plus 2 to the negative 1/2 with the 1/2 in front. Okay, and then 1 plus, keep dy dx, that's our slope of the tangent, which we're going to want to solve for at some point. Plus, and then we'd have 2 to the 1/2, and then times 1/2, 2 to the negative 1/2, and then again dy dx. Oh, I can see this one's going to be a big mess. Okay, plus 2 to the 1/2, and I'm regretting my decision about splitting it into x to the 1/2 and y to the 1/2. Okay, 1/2, and then 2 to the negative 1/2 here equals 0. Because if I'd left it as x times y, then I would have had 2 times 2 underneath a root sign, which would have worked out very nicely. Okay, well, we'll see where this goes. So we have 1/2, and then 2 plus 2 is 4 to the negative 1/2. But I'm going to write that as 1 over 4 to the 1/2, which is root 4, because negative exponent, bring it to the denominator, right? Okay, that is being multiplied by 1 plus dy dx, plus, and then what do we have here? We have 2 to the positive 1/2 times 2 to the negative 1/2, and when you multiply powers, you add the exponents. So 1/2 plus negative 1/2 would be 0, so 2 to the 0 is 1. Yay! Okay, so then we only have the 1/2 left there, dy dx, and then plus, oh, we got that same trick happening here. So again, 2 to the 1/2 times 2 to the negative 1/2 would be 1, and I'm just left with 1/2 equals 0. Okay, we're getting there. So 1/2 times the root of 4 is 2, so 1/2 times 1/2 would be 1/4, and then brackets, 1 plus dy dx plus, and not much we can do with this, plus 1/2. Okay, now I guess we got to multiply that 1/4 through. I'm feeling like there might have been an easier way, but I don't know. Okay, so we multiplied the 1/4 through, and pretty much everything else stayed the same. And now the dy dx terms we want to put together, the numbers we want to take to the right-hand side. So 1/4 dy dx plus 1/2 dy dx would be 3/4 dy dx. Then 1/4 plus 1/2 again for the constants would be 3/4, but we're going to move it to the other side, so -3/4. And then we divide both sides by 3/4 to isolate dy dx, and we would get -1 would be the slope of the tangent line. All right, well, that came out nice. It was a little ugly in the middle there, though. Okay, alrighty, hope that helped.